As a demonstration of the advanced capabilities of APEX, we're going to look at an idealized design of an LED-based lamp, such as might be found in an operating room or surgical theater lighting. We've created an exploded view of the lamp and can see the base design, which includes a lens, a patterned reflector, and an array of LEDs, as well as a handle and a top and bottom cover as part of the mechanical assembly. We'll start with the main pattern lens. Notice that the base lens is constructed from a revolved aspheric surface. This surface is replicated in an array and then used to cut our desired lens pattern from a solid cylindrical block. Finally, we add a central hole to the solid part for the lamp handle. In similar fashion, the patterned reflector starts with a revolved surface from which we create an array of reflectors. We add a planar surface between the reflectors and then thicken the entire surface to create the solid part. Lastly, one of the neat features of APEX is the ability to rapidly create arrays of LEDs or other sources. In this case, we can take a sketch pattern like the one used to create the lens and reflector arrays and generate an array of LEDs according to our prescribed pattern. We'll collapse the assembly view and if we look at the assembly up close, we note that the LEDs are slightly misaligned to their respective reflectors. We'll examine the effect of this misalignment in just a moment. Under the APEX Optics Manager, we can quickly assign media and coating properties to the lens and to the reflector, and these are the main optical components of concern to us. In addition to our ability to rapidly create patterns of sources in APEX, we can also select groups of source geometry with the Optics Manager and easily assign a manufacturer's ray data file to all sources simultaneously. Again, this makes the process of creating multiple sources within APEX fast and intuitive. Now, we've already performed a ray trace for this system, and we can see the rays plotted within our 3D view. From the Analyze tab, we examine the lamp's far-field luminous intensity and note that the majority of the flux is contained within a 25-degree angular cone about the normal to the lamp. We can also see that the intensity is not symmetric about the center due to the LED misalignment we showed earlier. A quick view of a 3D contour plot helps clarify the angular flux distribution from the misalignment. We've also performed a ray trace with a detector, which we can now see within our 3D view. We'll plot rays from the new trace and note that the rays now propagate to our detector plane. From the Analyze tab, we can perform an illuminance calculation at the detector and can see the roughly Gaussian profile of the flux distribution. A 3D contour plot again provides a visual reference for the distribution of light from our lamp onto the detector surface. This example of an LED-based surgical lamp demonstrates how quickly and easily real-world performance can be simulated within the APEX environment. Contact a Bro representative today to learn more.